system. Now the members of this group is myself, Dwight Downer.
Myself, Martin Dillon, Kimani Taylor, and Brad Ford.
Alright, that's our group member. David is currently missing right now. He was here working on the circuit, so he should also take credit for what's taking place right here. Alright, so now, what is semi-automatic control system? Now, the semi-automatic control system is a control system used to safely change the supply of power to a load from the normal power supply to that of an emergency or backup source in case where the primary power source has failed or has been disconnected from other reasons like maintenance. Okay? Now, here we have the wiring connection for the semi-automatic control system. Now, the parts of this system is we have both isolators, one for GPS and one for the generator itself. We also have a control relay and we have two contactors, one for GPS and one for the generator, and in between we have a mechanical interlock contactors for safety. Also we have our distribution panel right here. Now, why is it called a semi-automatic control? Some effort is needed as human to control certain aspect of the circuit, while others are mechanically or electrically controlled. So that's why it's called semi-automatic control system. Now let's look at the operation of this circuit. We have JPS coming in, JPS power source coming in, right? Turn on isolator. What happens is that this control relay card becomes energized. You normally close contacts and they become closed, and normally open become closed. Right? Once that is done, the contactor for JPS will now become energized, thereby supplying power to the distribution panel. Now at the same time, this contact cannot be energized. If the generator was on, this contact cannot be energized because of the mechanical interlink and also based on operation of the control relay, which is energized to ensure that only the JPS contact is energized, supplying power to the distribution panel. Now, in the event that there's a power cut, or JPS, there's no power, there's an outage. The generator, we have to manually turn on the generator, that's for sure, because it's not automatically turned on. So once the generator is turned on, what happens is that once there's a power cut, this control relay is going to become de-energized. So that contact that was energized and become closed is going to return back to its normal position, normally open and normally closed, thereby energizing this generator contact right here. Now the generator contact will now be energized, thereby supplying the generator voltage to the distribution panel as a backup power source for the circuit itself to operate. Now, let's say that we need to service the generator. The first thing we do is we service the generator. If we have power source, yes, we can turn on JPS, allow JPS power source come in, but we have to turn off the generator and we can do whatever form of maintenance and service on the generator itself in the event of damaged generator or so forth. So that's basically how the semi-automatic system works. Now the application of such system. This system can be used where we need backup power. For example, in the hospital, let's say that there's a power outage. The automatic power controls will be able to switch over to the generator once the generator has been started to supply power to the hospital. Same thing in case of, let's say, a bank, right? JPS is a power outage, you turn on the generator, and the power travels to the distribution for energizing the circuit itself. That's basically how the semi-automatic control power distribution system operates in a nutshell.
So today we will be carrying out 3 electrical tests: the earth continuity test, the polarity test, and the ring continuity test.
Alright, so the first test we're going to be doing on this circuit is earth continuity test. Now the reason why the earth continuity test ensure that all metal fixtures are connected directly to earth. So when we're doing earth continuity test, first we put the meter on continuity. What is it, please? We're going to find the earth conductor, connect one terminal of the meter to the earth conductor, and put the metal dots. We're showing here in a peak. So we're here in a peak right here. So now we're going to be performing polarity tests. Now the reason why we conduct polarity tests is ensure that Each conductor is connected to their respective terminals within the circuit. So we're going to check to see if the live conductors are connected to their respective area, and the neutral conductor is connected to their respective area through the circuit. Now when measuring continuity, use a digital multimeter, the meter and continuity. Alright? Now how we know a meter is on continuity when we put two terminals of the meter together with pair of B. So now we're going to be measuring continuity on this 190 left over the generator section. And when measuring continuity, all switches should be on within the circuit. The generator isolator switch is on, breaker switches are on, and we have to manually press the contactor because it's an electromagnetic switch, so we have to manually press that switch. So the 190 LED, measure on the load side of the contactor, the line side rather. So on the line side we get a beep. When I depress the contactor, now on the load side, we should also get a beep. So continuing, in the breaker panel, and the main breaker, 190 LED we get a beep. Also, on sub-circuit breaker, we should also get a beep on the 190 LED. That's how we know there's continuity. Now we should not get continuity on any other terminal, just to show you that this yellow terminal is not linked to any other terminal, live terminal right here to create any form of short circuit. Right? So now we're going to do continuity testing on another conductor. I'm going to be using it on the neutral conductor. Right? So we're going to measure it. This neutral conductor travels directly to the breaker panel and it is connected right here. Right? That's good. We're going to check on the load side to see if it's connected as well. There we go. Right? So we're going to measure one more conductor. I'm going to be measuring the red terminal, 220 conductor terminal. All switches on the line side of the contact. We get our beep. On the load side, we also get our beep. On the main breaker, we get our beep. And also on the sub-circuit, contactor press. The meter is off. Meter just went off a while ago. So here we go. Check again. There was a problem with the meter. There we go. There we go. The meter went off. So there's basically continuity in terms of the respective terminal that the conductor should be connected. Now the last test we're going to be performing on this circuit right here is a ring continuity test. Now there are other tests such as insulation resistance test, but those tests cannot be conducted on the circuit. Reason being, yes, the control relay has a coil, electromagnetic coil, and also the contactors also has coil. And they're going to be given incorrect reading for insulation resistance test. Now, to construct the ring, to do the ring continuity test, we are going to connect all the conductors on the load side. On the sub-circuit section, we're going to be twisting all these conductors together. Twisting the live, the neutral, earth itself can remain. So, here we go. We leave the earth and we twist the live conductors and neutral conductors together. Now, why do we perform ring continuity test? Ring continuity test is done to ensure there is a complete path of current flow from the source through the circuit and back to the source. And unlike, just like polarity test, all switches should be on within the circuit. All switches should be on. So we need to depress this contactor, again just the same, and the meter is also placed on continuity again just the same. So we know we're getting the beep. Now to perform this test, the doubling test on the meter, we're going to be testing it from the generator section. So we're going to press the generator contactor. There we go. And on all of these conductors, we should be getting a beep. Right? That's how we know that there's a complete path of current to flow. So what I'm going to be doing now is that I'm going to be disconnecting the neutral conductor. And I'm going to allow 220 and 190 conductors to twist to ensure there's a complete part of the current flow. So the neutral conductor is disconnected. And we're going to be measuring between 190 left, 220, and keep these out of the way. Earth and the neutral. So we should get continuous speed. There we go. So there's a complete powerful current to flow throughout the circuit. So that is how we perform polarity tests, ring continuity tests, and earth continuity tests.